We're probably not the only company that knows about other compliance methods for the Ontario Building Code, but I'm certain we're the most qualified companies to serve your needs in this matter. We treat you like you're our only client. With our responsive personal service, getting hold of us is never a problem. We want to help you build a better and more cost-effective product so your clients can live a more energy efficient, comfortable, durable, and healthier home. As a resident of the globe, my ultimate goal in life is to help my clients run a more successful business so we can all live a fulfilling life by creating a more sustainable environment for many generations to come. Now, take a moment and ask yourself, if you can get a hold of the system and tools today, will you take a leap of faith and try it out or continue doing the same thing you've been doing for the past years? Of course, if you choose to try it out, you need to meet at least 4 of the 5 conditions I mentioned above when building a house. If you feel all 5 are important, we will have a great time working together and making your next project a successful one. Our service and system are a combined effort of 10 dedicated minds and over 100 years of hands-on experience. Al and I are business partners and we're all part of the AJEC family. Our system has already been applied to over 10,000 homes in Ontario, other parts of Canada, and foreign countries around the world. The simulation tool we use has rated over 1.5 million homes across Canada and over 2 million homes globally. In less than 12 years of time, I believe 99% of new and existing homes in Canada will be rated using this exact same software. By working with us, you'll learn our system and tools. You'll learn how to build cost-effective, energy-efficient, comfortable, durable, and healthy homes. Imagine knowing that you have done something right and meaningful. Do you enjoy this feeling? If you can have this feeling right now, how much is that worth to you? 10,000? 8? 5? 3,000? I will end my introduction here and leave it to you to answer this question after my presentation is over. Without further ado, let us begin learning the 8 secrets you must know about SB12 to win big. Let us all be the other 10% and outperform our competitor without them even knowing it. During the next 15 minutes or so, we will do a brief SB12 prescriptive compliance path overview. Once we understand the mandatory requirements in the prescriptive path, we can then understand the requirements for the performance compliance path. Finally, we will get to the meat of this presentation, the 8 secrets to using the performance path to win big. Please take a bio break as needed. We will not stop once the training session begins. If you belong to one of these professions, you should take this training. Architects and designers need to know how to design to comply with the energy efficiency requirements of the building code. Building officials, they would need to know more than anyone else in order to properly perform plans review and on-site inspections. Myself, as an energy advisor, should know more so I can help my clients to get what they needed and make their project a successful one. Homeowners who are thinking of doing a house addition, today is your lucky day. You'll learn 3 different ways to comply with the building code requirements. HVAC designers are impacted by the way we're designing and building our houses. Depending on how we choose to comply with the building code, their work will be impacted by our choices. Manufacturers and suppliers should keep their knowledge base up to date. Otherwise, selling outdated or in-compliance product can be a huge liability. Realtors, the more you know, the more added value you can offer to your clients, resulting more sales. Renovators, general contractors, residential builders, and developers. Needless to say, all these people live and breathe this information on a daily basis. Knowing your options will always benefit you both mentally and financially. To start our training, I would like to introduce some new words to this group. OBC stands for Ontario Building Code. This is the legislation we need to follow when we build homes in Ontario. SB12 stands for Supplementary Standard. This is the energy efficiency requirements for low-rise housing in Ontario. NRCan stands for Natural Resource Canada. They are in charge of Canada's natural resources. H2K stands for HOT 2000. This is the energy modeling software developed and maintained by NRCan. R stands for thermal resistance in imperial units. Higher is more energy efficient. RSI, thermal resistance in metric units. Higher is more energy efficient. To convert RSI to R, simply multiply it by 5.678. Nominal RSI stands for rated insulation value of the material, for example, R20, R22, or R24 bats. Effective RSI is the blended thermal resistant value including thermal bridging. U stands for conductivity, which equals to 1 over R. Lower is more energy efficient. ER stands for energy rating. Higher equals to more potential for solar heat gain. SHGC, solar heat gain coefficient, is the amount of free energy from the sun through the glazing. AFUE, annual fuel utilization efficiency, higher the better. HRV, ERV, heat recovery ventilator / energy recovery ventilator. This is the dedicated fresh air machine for your house. SRE, sensible recovery efficiency, higher the better. It is used to rate the effectiveness of heat transfer for HRVs and ERVs. EF is energy factor, hot water heater performance factor, higher the better. DWHR, drain water heat recovery, is the copper pipe for preheating incoming water from the city, a perfect match with tankless hot water heaters. The last three are three different metrics to comply with air tightness requirements for OBC. ACH, air change per hour. ACH is simply the volume of air leaked per hour divided by the volume of the building. NLA, normalized leakage area. It is an estimate of how big of a hole the building envelope has. NLR, normalized leakage rate. It is a measure of how much air is coming through or leaving these holes through the building envelope at a specific pressure. Like the other components, for air tightness compliance, you only need to meet one of the three metrics mentioned above, not all of them. There are three ways to comply with Part 9 of the Building Code. Prescriptive and performance compliance are two of the options. Today, we will not discuss the other methods. We will discuss Energy Star for new homes and other programs on a different occasion. There are many roads that leads to Rome. Either path above will get you there. Please note that for the first time in history, OBC SB12 has brought us different equivalencies to comply within the same component. Minimum nominal RSI. Max U, minimum effective RSI. If you forget what they meant, please refer back to the earlier slides. In general, nominal is always greater than effective due to thermal bridging. Looking at the example on this slide, R60 attic has an effective R of 59.22. The math shown here is another illustration of the relationship between R, RSI, and U. U equals to 1 over R effective. So 1 over 10.43 R equals to 0.096. To convert RSI to R, multiply RSI by 5.678. Therefore, 10.43 times 5.678 equals to 59.22. Table 3112A. Zone 1. Compliance packages for space heating equipment with AFUE 92%. Zone 1 includes places that have a heating degree day less than 5,000. This includes most of Southern Ontario and a majority of my client base. After December 31st, 2016, this is the table you must follow today if you are planning to submit a new building permit. There are 6 prescriptive options you can use for meeting compliance, A1, A2, A3, all the way to A6. If you're using a combo system, one appliance that does both space and hot water heating, you must follow the A4 requirement. In Ontario, most builders follow the A1 package, and I will explain why shortly. To comply with A1, you must follow all the components shown on the chart. Starting from the top, ceiling with attic space, all the way down to domestic water heater. Once again, you can comply with the ceiling with attic space by meeting any of the 3 thermal values listed on the chart. Understanding these options is like learning 3 different languages: English, French, and Mandarin, for example. This means as long as you show your component for the ceiling with attic space is R60 or U 0.017 or R effective 59.22, such assembly is deemed compliant. For ceiling without attic space, you'll meet compliance when the component is either R31, U 0.036, or R effective 27.65. Pretty straightforward, right? Looking at the exposed floor, you'll meet compliance when the component is either R31, U 0.034, or R effective 29.8. Now, let's hold for a second here and think. Why is R31 applied here gets a higher R effective compared to the ceiling without attic space? This discrepancy is due to how we calculate the impact of thermal bridging for different assemblies. More wood is less room for insulation, therefore lower the effective thermal performance of the assembly. So far so good? Great. Moving on. The next component is what makes A1 the most popular prescriptive package most misinformed builders like to use in Ontario. Let me repeat this again. A1 is the most popular prescriptive package most misinformed builders like to use in Ontario. Let me first explain what makes it popular and later on explain where the misinformation happens. Looking at other options to the right, you'll see an acronym called CI. In all the other options, CI stands for Continuous Insulation. Yes, exterior rigid foam board is one of the options to meet CI. In general, you would agree that whenever you add exterior foam board onto your wall, will increase the cost of the project. A1 is the only package that does not have this requirement for walls above grade. If cost is on top of the priority list, then A1 is the package by default. Again, I will later on explain where the misinformation happens. Write down your thoughts for now. Moving on to basement walls. This is where you'll see that the nominal R is less than the effective R. Remember, nominal R is the rated value of the insulation material itself. Effective R is the blended effective value of all the material used in the assembly. This includes the 8-inch thick foundation wall, the R20 blanket itself, and the air film in front of it. This is why the effective R is higher than the nominal R in the next few components. As you can see on the chart, basement wall in all packages has the CI acronym. This means you need to provide an uninterrupted layer of insulation to protect the foundation wall. This can be a problem when you don't have enough space in the basement to allow such arrangement. For an example, picture a 16-foot wide townhouse being developed in Markham, Ontario. You have 10 feet for the garage, 3 feet for the hallway, and you have 3 feet left for the basement staircase. In the previous SB12 requirements, you're allowed to insulate and stud right against the foundation wall. Due to the CI requirement, you now must move your studs away from the concrete foundation to comply with the R20 CI requirement. Sometimes you might not get the minimum clearance requirement between the foundation wall and the staircase for your hallway in the basement. This is a real challenge. However, don't worry, I've got a solution for you. I'll share it with you later on during this session. The next 3 components are for your slab. For below grade slab, where the entire surface is greater than 600 millimeter below grade, which is about 2 feet, you do not need to provide any insulation. Heated slab or slab that is less or equal to 600 millimeters below grade and edge of below grade slab less or equal to 600 millimeter below grade must also be R10 or greater. This sums up the requirement for the opaque assembly of a new home in Ontario. For your windows and sliding glass doors, you'll need to learn 2 other languages, Italian and Spanish. To comply with this component, the product must meet a U of 0.28 imperial or U 1.6 metric or an energy rating of 25 or higher. Again, you only need to meet either one, not both. You will soon see why this is important. For skylights, you must only comply with U of 0.49 imperial or U 2.8 metric units. For your space heating equipment, a minimum AFUE of 96% is required. For the HRV or ERV, a minimum SRE of 75% is required. For the domestic hot water heater, a minimum EF of 0.8 is required. And finally, although it is not on the official table 3112, we all should know that a minimum 42% drain water heat recovery unit connected to 2 or more shower is required in any of the prescriptive packages shown here. Once you understand how to read one prescriptive package, you should be able to read and understand the other options. I understand this is a lot of information to absorb within such a short timeline. If you feel that was too quick of an overview for the prescriptive path, please find me on LinkedIn and join this group. We can answer all your SB12 related questions there. The purpose of this group is to increase the level of knowledge on Canadian housing energy efficiency programs, Ontario Building Code compliance options, and promote capacity building in the industry by offering free online training through an online Q&A platform from trusted sources to the general public, potential and new registered energy advisors in Canada and globally. If you feel this is helpful for others, please share this news with them. This group will remain free to join forever. This is a sample effective RSI value calculation in Appendix A of SB12. As you can see, to calculate the effective RSI value of an opaque assembly, you must first know how to build it. Afterward, it's just about assigning the appropriate RSI value to each element. Luckily, you can hire a qualified individual to do this for you. For example, you can see that the R31 bat blended with the 2x10 joist gets you an effective RSI of 4.46. The total effective RSI value for this assembly is 5.25, which is A1 compliant. Without doing these complicated calculations, SB12 already gives us some flexibilities in wall options. For an example, where you need to install R20 CI for your below-grade walls, you're allowed to use R10 CI plus R12 bats instead. Although these assemblies are deemed equivalent, they do not perform the same. Here's why. When you perform the effective RSI calculations for these assemblies from the previous slide, you will see that the total effective R value is slightly higher for the R20 blanket option. In case you feel lost here, don't worry, this is not something I expect you to understand right away. Just remember that each wall assembly performs differently if the construction configuration is changed. The good news is that if you want to learn how to do this for yourself or include it as a new service to your clients, you can take the Introduction to HOT 2000 Energy Modeling for OBC Part 9 SB12 Performance Compliance Training. This sums up what I wanted to tell you about the prescriptive requirements for today. Moving on to the performance compliance path. SB12 Performance Compliance is the first option you can check off on the Performance Energy Efficiency Design Summary form. You would recognize this form if you had used this method before. As you can see, you will need to provide the energy performance results using an approved software as part of your submission to the building permit department. So the question comes, what are the rules I must follow for this path? Yeah, this is where all the fun begins. As Albert Einstein once said, you have to learn the rules of the game and then you have to play better than anyone else. So here are the rules. Rule number 1. The first rule requires you to estimate the annual energy consumption of both reference and proposed building design, expressed in gigajoules. Rule number 2 says you also need to compare identical buildings so that it is an apple-to-apple comparison. Sometimes, when your design is over 22% window-to-wall ratio, let's say 30% for example, the proposed building design will include all of the windows in the energy simulation report. The reference building will only have 22% windows-to-wall ratio in the report. This is to ensure that homes with higher windows-to-wall ratio will still be just as efficient as the building code minimum by increasing the energy efficiency of the other components of the house. For example, Adding exterior insulation onto the exterior walls to compensate for the increasing energy consumption due to a larger window area. The third rule asks us to prove that the energy consumption of the proposed building design must be the same or less than the reference building design. If the simulated annual energy of the reference building is at 100 gigajoule, then the proposed building design must be 100 gigajoule or less. Rule number 4 tells us to select a reference building design from table 3121. These are the A1 to A6 prescriptive options I showed you earlier. You must follow all of the components listed for the specific prescriptive package. Again, you may not pick and choose components requirements from different packages. Rule number 5 says you must use a recognized software. We use HOT 2000 only because this software has been around for over 35 years. Over 1 million homes in Canada and around the globe have been rated using this software. Rule number 6 is an important one to remember. It states that we are allowed to downgrade the thermal envelope up to 25% worse compared to the reference building. This is my favorite rule because it allows so much flexibility for our proposed building design. I will show you how this works momentarily. Finally, the last rule states that the proposed house must comply with all the requirements stated in section 311. For an example, if your window to wall ratio is between 17% and 22%, the performance of your windows must be upgraded to the next performance level from the basic requirement. Let's say you were going to use A1 as an example. The window performance requirement should be either U 0.28 imperial, U 1.6 metric, or ER 25. The next performance level would be U 0.25 imperial, U 1.4 metric, or ER 29. In addition to the 7 rules I mentioned in the previous slide, Table 3121 specification for the reference and proposed building design lists all the permutations and restrictions one must follow in order to comply with using this method. It gives you very specific guidance on how to model your reference building and the proposed building design. For an example, the wood frame stud spacing for above grade walls in the reference building design must be 406 mm, which is 16-inch on center. Also, occupant loads, internal gains, and operating conditions for both designs must be the same. Now that you know the rules, let's play it better than anyone else. This is how I play the game. This is our 8 secrets on SB12 you need to know to win big through the AJ Easy Way. All these strategies are created to provide practical solutions to real-life applications.